Lesson 34 is graphing linear equations 2. Obviously, we've already done that. This year, we're just going to do it a little bit further. All right, determine whether each group of points represents a linear function. Well, we've got 3 points here. Okay, one thing we could do is we could just graph it out and see what it looks like. Negative 3, 0, 0, 2. I don't know, those look pretty even in there. Would it be? Well, I can't really tell by drawing it. I mean, I drew a line in there, but could it be more like that? Where that's not a straight line? Well, we need something more than just looking at it this time. So I wouldn't necessarily just graph this thing out. Instead, what I would do is I would see, all right, what's the slope for these? Remember, slope is y2 minus y1 over x2 minus x1. And what I'm doing here is I'm finding the slope between the first two. And what we have is 2 minus 0, and 0 plus 3 would be 2/3. Now, if the slope is 2/3 for all of the points, then it's got to be that they're all on the same line. So let's do these next two. We've got 4 minus 2 over 5 minus 0, 2 over 5. Slopes are different. Right? Because the slopes are different, then these are not on the same line. Alright, so as soon as you do that, yes, I could have done the first one and the third one. Okay, and if I did that, we'd have 4 minus 0 and 5 minus negative 3, 4 over 8. Gets it down to 1/2. None of those match up. So even though it was really close on the graph, you do have to do some actual math here to see if they actually are or not. Do the same thing for this next one. Find the slope between them. So 2 minus 0, 0 minus negative 4. We would have 2 over 4 is 1/2. Okay, 3 minus 2, and 2 minus 0 is 1/2. That was the second and third one. Now I've got to do the first and the last one. 3 minus 0 over 2 minus negative 4. 3 over 6. It's 1/2 for all of them. So yes, these would be on the same line. Alright, and that's pretty much how you tell. Okay. Yeah, and we do have different forms of linear equations. Standard form, slope-intercept form, point-slope form. The one that you guys probably know the best is slope-intercept form, which is y equals mx plus b. Remember, m is our slope, b is our y-intercept. Standard form, remember, that is when x and y are on the same side. So that's ax plus by equals c. Remember, a has to be positive, and you cannot have any fractions or decimals in there to be in standard form. Point-slope form is a little bit different. It's actually one of the easier ways to graph it, right, because of what the equation tells us. Point-slope form is y minus y1 equals m times x minus x1. Well, m is still our slope, just like it was up here. This x1 and this y1 is a point that's on the line. So it is actually very, very easy to be able to graph that, and I'll show you that in just a second. Say we needed to graph these. Well, there's lots of different ways to do it. Okay, let's say, well, this one is in standard form. Okay, what a lot of you guys are going to do is you're going to put it into slope-intercept form, which is totally fine. So you'd move the x over, and then you'd divide by 3. So you'd have negative 1/3 x plus 4. Alright, so what we'd have is we'd go up 4, 4, and then down 1 over 3. And then we draw that line in there. Okay, some of the rest of you like to do this, and I would actually do this time. I'd put an 0 in for x, find my y-intercept. That would mean this is a 4, okay? And then do the same thing for x. Well, this would be a 12 because that would be a 0. Right, the only problem with this is this runs off the graph, obviously, but as you can see, 0, 4 is right where our point was before. And if we did extend this line out, 12, 0 would be right about there. And so either way you want to do it is totally fine. It's up to you. Just get it on the graph, okay? Whether you do an XY chart or slope-intercept form or even point-slope form like this next one is already in. Let me show you the point-slope form is very, very easy here. All right, the first thing you need is you need to figure out what the point is that we have. Well, remember it was x minus x1, so we got to flip the sign here, so this becomes a 1. Flip the sign here, this is a -2. This line goes through that point. So we're just looking at the graph and we know there's a point on the line. And then it says our slope is 2/3, so we'd go up 2 over 3. And there's approximately what our graph would look like. Now, what a lot of you are going to do is you're going to say, well, I want to put it in this slope-intercept form. And that's fine, you can totally do that. But look at all the extra work that you have to do. You got to run the 2/3 through there. So we've got 2/3 x minus 2/3. And then we got to subtract 2 from both sides. So we've got y equals 2/3 x minus 2 and 2/3. That looks terrible, the graph. Okay, well, what we'd have is we'd come down 2 and 2/3, so it'd be right where the line is. And then from there, our slope is 2/3, so we could go up 2/3 and over 1, or we could go up 2 and over 3, and all those points are still on that line. So I would if it's in point slope form, I'm going to do that every time just because it's much, much faster and easier to do. Alright, now our last one. Graph each transformation of x and describe the change. Alright, well, what I have on there first is the y equals x line. Alright, our first one, it says here, is g of x equals 4x. Well, we know that the number attached to the x here is our slope. Okay, and there's no number added on to the end here. So, this one, we would just rotate around. See if I can do this. And our slope would be up 4, count right, there we go, up 4 over 1. So there is our graph. Alright, so we have a vertical transformation here, okay, where we are taking our slope and multiplying it by 4. Our next one is x plus 2. Well, this line is already a slope of 1, just like it is here. Alright, and it says that plus 2, that just means move everything up 2. And there it is. Alright, so if I were to describe this change of the f of x equals x line, I would say, well, every point on the line moved up 2. Alright, our next one is negative 2x. Well, that just means our slope is not positive anymore, it's negative. And our slope is negative 2. So it'd be right about there. Alright, so what we'd have for the change is the line is still pretty much the same, but it has flipped over the y-axis to make it a negative slope, and it becomes steeper because of that. Alright, then our last one, 2x plus 1. Well, we've got a slope of 2, so it goes kind of like that. And then we've got a y-intercept of 1, so we're moving the entire thing up 1. And there's our line. And that is how you would do that, along with describing the changes that are going on along with that. Any questions, please let us